Hello everyone, my name is Khalid Giabal from Group 3 and my topic for today is Roots on Probability Demonstrator. So pag-uusapan natin yung mga probability ng mga roots dito sa specific Galton board. The object shown at the left is called the Galton board or probability demonstrator. It was invented by the English statistician Francis Galton. This particular board has 256 small red balls that are released so that they fall through an array of hexagons. So yung figure sa left side is yan na yung Galton board or tinatawag na nating probability demonstrator. It was invented by Francis Galton, which is yung particular board na yun or yung original Galton board ay mayroong 256 small red balls. But as of now, marami na rin gumagawa ng mga Galton board, which is iniiba nila yung color ng mga ball at saka yung quantity niya. So, the balls are released so that they fall through an array of the hexagon. So pag sinabi nating array of the hexagon, ito na yung arrangement. As you can see in the figure, yung mga arrangement ng mga hexagon na para siyang nagfo-form na triangle. So, the board is designed such that when a ball falls on a vertex of one of the hexagons, it is equally likely to fall to the left or to the right. So pag sinabi nating vertex of the hexagon, ito na yung sa dulo ng hexagon. So once na yung bola is mag-hit siya dito sa vertex of the hexagon, it will either go left or right. As the ball continues its downward path, it strikes a vertex of a hexagon in the next row where the process of falling to the left or to the right is repeated. So yung mga bola na yun is, as I said kanina, it hit to the vertex of the hexagon and then it will either go left or right until yung pattern na yun is repeated. After the ball passes through all the rows of hexagons, it falls into one of the bins at the bottom. In most cases, the balls will form a bell shape. So kung nakikita nyo dyan sa figure, yung parang mga bin na yan is dyan na nahuhulog yung mga balls. So in most cases, it will form into a bell shape or also called a normal distribution. Ang normal distribution na yun is one of the features of the Galton board. It is formed as a bell shape shown in the Galton board. That means the distribution of the ball is symmetrical. So yung distribution ng ball, kapag lahat ng mga 256 small red balls na yun ay nahulog na dun sa bin ng Galton board, it form into symmetrical. Pag sinabi nating symmetrical, it is balanced proportion. Another one is binomial distribution. It is a probability that a ball will fall into any of the bin of the board. So yung binomial distribution is hindi siya yung pangkalahatan ng normal distribution. So let's say what are the probability that 4 balls will fall into one of the bin. So yun na yung tinatawag nating binomial distribution. There is also one thing called the central limit theorem. In central limit theorem, when you add independent random variables, their sum tends toward the normal distribution. It demonstrates that the binomial distribution approximates a normal distribution. So yung central limit theorem is kapag inad mo na yung lahat ng mga probability sa random variables is magkakaroon ng normal distribution kung saan ang binomial distribution approximates a normal distribution. It means kahit ano pa yung binomial distribution mo is nandoon pa rin siya sa normal distribution. So bakit nga ba nag-form ng normal distribution? So yung bell shape na yun is the reason kung bakit nagkakaroon ng bell shape doon sa Galton board is that the ball is more frequent to fall at the middle kasi nga there is this one called Pascal's triangle kung saan yung number sa hexagon is mas marami kaysa sa pinakagilid. So what is Pascal's triangle? It is a triangular array of numbers in which those at the ends of the rows are 1 and each of the others is the sum of the nearest two numbers in the row above. So yung Pascal's triangle is array of the hexagon. So gaya rin doon sa Galton board kung saan yung edge niya is number 1 because yung 1 na yun is there is only one roots for a ball to take para mapunta siya dun sa bin ng Galton board. And then the sum is the nearest two numbers in the row above. It means yung pinakataas ng isang hexagon is i-add mo siya. So let's make a sketch to make it more understandable. So I made a sketch for the Pascal's triangle. So gaya ng definition ng Pascal's triangle, lahat ng edge niya ay number 1. So let's put the number 1 at the edge of the Pascal's triangle. So ayan na. So yung first hexagon is also a number 1 because yan yung if the ball will fall to this hexagon, there is only one roots to take. So dito naman sa middle, we add the two nearest number above, which is ito yung 1 plus 1. So 1 plus 1 is equal to 2. And then in this hexagon, we also add the two nearest number of the hexagon, which is the 1 and 2. So 1 plus 2 is 3. Also in this hexagon. So 1 plus 3 is equal to 4. 3 plus 3 is equal to 6. And 3 plus 1 is equal to 4. So i-add mo lang siya yung two nearest number above ng mga hexagon hanggang sa makumpleto mo na yung Pascal's triangle. So as you can see in the Pascal's triangle, the large number are in the middle. So that is the reason kung bakit kapag i-release mo yung ball sa Galton board, the more frequent is yung sa middle. So it will form into a normal distribution or yung bell shape. So yung sketch ng Pascal's triangle na ito ay gumawa tayo ng row 7, which is yung pinaka first is yan na yung row 0, row 1, row 2, row 3, row 4, row 5, row 6, and row 7. So there's also another beautiful features of this Pascal's triangle. If you add them diagonally, it will form into Fibonacci sequence. So 1, this is 1, and then also 1 plus 1 is 2. 1 plus 2 is 3. And then 1 plus 3 plus 1 is 5, and so on. So as you can see, 1, 1, 2, 3, and 5 is the form of the Fibonacci sequence. Let's try to answer some exercises to apply the Pascal's triangle. Number 1, how many roots can a ball take as it travels from A to B, from A to C, from A to D, from A to E, and from A to F? So we will have the figure on the next page. Number 2, Allison wishes to walk along the streets from point A to B. How many direct routes without backtracking can she take? So in question number 1, the answer is from A to B, there is one route for a ball to take in that hexagon B. From A to C, there are 4 routes for a ball to take in the hexagon C. In hexagon D, there are 6 routes for a ball to take from that hexagon. In hexagon E, there are also 4 routes to take for a ball to go from that hexagon. In hexagon F, there is only one root for a particular ball to take from that letter F. To make it more to check the answer, let's solve the problem using the Pascal's triangle. So as you can see in the figure, there are 4 rows. So ito na yung B, C, D, E, and F. And ang letter A is yung dito. So in this hexagon, there are 1 roots to take. There are also 1 roots to take from the row 1. And then in this row 2, there are 1 root to take from a ball to go here. And then there is 2 roots for a ball to go here because 1 and then 2. So that is the total of 2 roots. In this right side, there is 1 root to take and also 1 from the edges. So 2 plus 1 is 3. 2 plus 1 is also 3. So in this letter B, so yung answer natin is number 1 because nasa edge siya. So this is 1 root. In letter C, we add the 2 nearest number above, which is 1 and 3. So 1 and 3 is equal to 4. And then in letter D, we also add the 2 nearest number above. So 3 plus 3 is equal to 6. So 3 plus 1 is equal to 4. And then yung F is nasa edge siya. So there are only 1 root. So ang answer is 1, 4, 6, 4, and 1. Again, in question number 2, Alison wishes to walk along the streets from point A to point B. How many direct routes without backtracking can she take? So the answer is 35 routes. So bakit nga ba 35 routes? Let's make a sketch para ma-check natin yung answer na 35. So we imitate the sketch from the figure. So paano na ba natin malalaman na 35 yung dito sa point B? To know that, first is let's put yung bawat route is yung dito sa corner ng mga buildings, like this one. So dyan tayo maglalagay ng mga number. So again, let's apply the Pascal's triangle. Yung nasa edges, which is yung dito na side, and dito is 1. So after we put 1, we add the 2 nearest number above, which is 1 plus 1 is equal to 2. And then 2 plus 1 is equal to 3. 3 plus 1 is equal to 4. 2 plus 1 is equal to 3. 3 plus 3 is equal to 6. Then 6 plus 4 is equal to 10. 3 plus 1 is equal to 4. 6 plus 4 is equal to 10. So this is also the edge. And then 4 plus 1 is equal to 5. 10 plus 5 is equal to 15. Then 10 plus 10 is equal to 20. And the last addition, 15 plus 20 is equal to 35. So yan na yung answer, 35. And as you can see, yung city map is, kapag binaliktad mo siya pa ganyan, is para siyang Pascal's triangle. So the summary in this report, the Galton board are used for statistics and can also used for determining en routes. So yung reason talaga ni Francis Galton for inventing the Galton board is for more likely for statistics tsaka yung sa mga research. And then, the Galton board have a lot of features like normal distribution, binomial distribution, central limit theorem, and the Pascal's triangle kung saan i-tackle natin siya. We can use Pascal's triangle method in real-life situations like determining how many routes will take for us to go from the specific location. It can also apply for city maps, chess, and more. So, gumawa tayo ng mga exercises like sa number 2 which is the city map, kung ilan ba yung iti-take ni Allison to go from point B, kung saan na-apply natin siya sa real life situation, and also sa mga chess and many more. So that's all for my report. Thank you for watching.